Hello learners, welcome to NIOS Studio. This program is based on Senior Secondary Chemistry course. In the previous section, you have learned that liquids have definite volume but no definite shape and are almost incompressible and can diffuse. I am Dr. Alka Mehrotra. We will continue lesson 5, the gaseous and the liquid state. During this part of the program, we will discuss about evaporation, vapor pressure, surface tension and viscosity. Evaporation. Evaporation is the process by which liquid changes into vapor. It occurs at all temperature from freezing point to boiling point of the liquid, and evaporation is a process which we see in our day-to-day life also. Suppose if you are putting water anywhere, next day we don't find water, it means the water drop that has been evaporated. Now there are few factors that affecting evaporation. Rate of evaporation of liquid depends on temperature, surface area of the liquid exposed to the atmosphere, wind speed and humidity. Now how? Surface area, more the surface area, faster will be the evaporation. For example, spreading of clothes for faster drying. This is very common example which we see in our home. We never put cloth just a crumble form when we have to dry, we just spread it. Now why? Because when we are spreading, surface area is more and the cloth gets drier little faster than heat. If we supply heat to the liquid, evaporation is faster. The wet clothes dry faster in sun. Now in rainy days you have noticed it takes lot of time. Why? Because humidity is there, the moisture content is there. The increase in temperature increases the kinetic energy of the molecule of the liquid and the liquid evaporates at faster rate. And all this depend on intermolecular force. Stronger the force, fewer molecules escape. In alcohol, let's compare alcohol and water. Alcohol and water, if you just put one drop, so we will find alcohol evaporates faster. So what happens? In alcohols, the attractive forces are weaker than those in water. Hence, alcohol evaporates faster than water. You know that the liquid placed in open vessel evaporate faster if we compare these two. If however the liquid is allowed to evaporate in closed vessel, evaporation occurs, but after some time the level of liquid does not change any further and becomes constant. In the beginning, the rate of evaporation is greater than the rate of condensation. Now here you can see. First I have taken the open vessel, evaporation is seen, and the second you see the rather vaporization is more than the condensation. Then slowly vaporization is equivalent to condensation. So this is how the vapors which apply pressure on that, this is the vapor pressure. But as more and more molecule accumulate in the space above the liquid, rate of condensation gradually increases. After some time, rate of evaporation becomes equal to the rate of condensation, and equilibrium state is reached. These molecules exert certain pressure over the surface of the liquid. The pressure applied by the vapor on the liquid surface is known as the vapor pressure. So, the pressure exerted by vapors above the liquid surface when these are in equilibrium with the liquid at a given temperature is known as vapor pressure of the liquid. So, this is one of the properties. Now, what factors affecting the vapor pressure? The vapor pressure of the liquid depends on the nature of the liquid. It depends on the temperature. Vapor pressure increases with increasing the temperature. So when we are increasing the temperature, what happens? Kinetic energy is more. If kinetic energy is more, it means the velocity of the molecules are faster. They will just escape out. Okay, so the vapor pressure is directly proportional to the temperature. Then here comes one term, that boiling point. The temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure is called the boiling point. You have seen that what is the vapor pressure? Vapor pressure is nothing, just the pressure applied on the liquid surface is the vapor pressure. Now, when this vapor pressure is become equivalent to the atmospheric pressure, at that particular temperature, anything starts boiling, like in water. So, at 1 atmospheric pressure, boiling point is known as its normal boiling point. Now, there is a vast difference between evaporation and boiling. As I said before, evaporation is taking place all the time. This time also somewhere evaporation is taking place, because now also, like suppose if you see the ocean, river and all, with the help of the sun rays, the evaporation is taking place. But boiling cannot take place at all temperature. It takes place at a definite temperature. And what was that temperature? The temperature at which the vapor pressure is equal to the atmospheric pressure. At that particular temperature, boiling takes place. Then evaporation is a slow process because it is continuously going on. Boiling is a fast process. You have noticed when you have put water in a pan and the gas, it's a fast, at particular temperature it starts boiling. Now, evaporation occurs only at the surface of the liquid. So, we can say it's a surface phenomena. Only the molecules which are at the surface, they will get evaporated faster because they are directly in direct contact with the atmosphere. And boiling occur throughout the liquid. So, we can say boiling is a bulk phenomena. When water is boiling, it does not mean that water is boiling only at the surface. Water is boiling throughout. So, it is a bulk phenomena. So, there is a basic difference between the evaporation and boiling. Now, when a small quantity of water is poured on a clean glass plate, now I am going to tell you about the surface tension basically. When we take a small quantity of water and we pour on a clean glass plate, it spreads in all direction in the form of a thin film. You all have noticed. Now, but when we take a small quantity of mercury and is poured on the glass plate, it takes the form of spherical drop. You may say that you have not seen the mercury, but yes, you have noticed, you must have noticed any thermometer when it breaks, we find that mercury comes out from that. And if you try to pick those mercury droplets, it's very difficult to take it out. Why? And it is always in a spherical drop form. So, we can say it means there is some difference between the arrangement of the water and the mercury. Similarly, small quantity of water is poured on a greasy plate. It also takes the form of small globule like mercury. Please notice this thing. If you take the normal plate and put little oil on it and put water and both the plates, you will find the difference between the water droplets. Now, this shows that the behavior of liquid is controlled not only by the gravitational force, we can say the weight, but some other forces also act on it, which depends on the nature of the surface in contact. If the weight of the liquid is negligible, then as the shape is preferably spherical, like raindrops, soap bubbles, you find that they are the spherical shape because the area is lesser. Raindrops, basically we say it's a distorted spherical shape. It's not exactly spherical, but it is a distorted form. Okay, I'll explain the surface tension by this figure. You can see, we will compare the water molecules at the surface and the water molecule which is there in between the water. Molecule B lying inside the liquid is surrounded by other molecules and so is attracted equally in all directions. Hence, the net force of attraction acting on the molecule is 0. A molecule A which is lying on the surface is attracted more by the molecule lying in the bulk of the molecule, it means from the downside, than by the molecules lying above it in the vapor phase. Therefore, the molecule A experiences a net inward attraction or inward pull. As a result, surface behaves as it were under tension, because the surface is getting pulled by the water surface, because it is not the net force is not 0 here. We can say it means the tension is developed over there. So, here we can say as it is developed on the surface of the water, so the name is given to the surface tension. So, what exactly is surface tension? It refers to the amount of force performing per unit length and is perpendicular to the line on the surface of the liquid. So, surface tension formula is, we can say F upon L, or force per unit length, and it is denoted by the Greek letter gamma. Unit is Newton per meter. As you know, force unit is Newton and the L, that is length unit, is meter. So, we can say the unit is Newton per meter. Now, surface tension decreases on rising the temperature. When we are increasing the temperature, so what happens? Kinetic energy of the molecule is more, and that decreases the intermolecular force of attraction. So, consequently, the surface tension decreases. Now, surface tension we can see in our day-to-day life also. A few examples are there. First is spherical shape of liquid drop, that is what I told you just now. It takes the shape of the sphere because the area of that is lesser. So, wetting and non-wetting property means like water wets the things like cloth and all. Now, non-wetting property like mercury. If you put mercury like in thermometer, we jerk the thermometer before taking the temperature of our body, and it does not stick on the surface of the glass. So, we can say that this is a non-wetting property. I will explain this further later on. Before that, I will come to the capillary action, and I want to show you one activity of that. Capillary action. Before I show you this activity, I just want to tell you one example of that, which is of day-to-day life, that you have noticed that the plants carry water and minerals. And if you have noticed in your previous classes, like if you take a white color flower and you put in the ink, that is blue or red color, the water rises over there, and after some time the white color flower, you will find that it becomes the ink color. So, now I will show you the activity. This is the paper. Now, paper I am going to put in the ink. I have taken the ink. Reason is the ink water, because you can see it very clearly. I am not going to dip completely. I will just put the water, this you can see water I have taken. Rather, let me little bit fold it so it will be more clear to you. Just the end of this will be touching over there. Can you see it? See. Now, what is happening? You will find that, or I will do one thing for your better understanding. See, I will put it over there, and after some time we will see how much it has taken the water, because I have made paper touch only to the surface of the water, not more than that. And let us see how much water is raised on the paper. Now, let us check. See. So, have you noticed, maybe just not 1 minute also, 30 seconds, I put this only this much surface on the water surface, and it has taken water till here, you can see. So, this is the capillary action. So, how this goes? Water is taken by the other molecule, other molecule, other molecule, so it rises up. So, this is how it goes up. Is it clear? So, now you can see the water has raised till here. So, this is the capillary action. So, from the the molecules of water are getting raised up and up. So, this is again a property, or we can say this is again a surface tension. Okay, the other effect of surface tension is curved meniscus. What is a meniscus basically? You can see here I have taken water and mercury. In the water, if you put both in the test tube, we can see in the first test tube, this is the concave meniscus is formed when the particle of liquid are more strongly attracted to the container, that is the adhesion, and than the cohesion, causing to the liquid to climb the walls of the container. Now, this is very new to you. What is cohesion and what is adhesion? Now, what is the meaning of that? Cohesion means when the molecules are attracted towards each other, and the adhesion means when the attraction between the water molecule and with the surface on which it is kept. Like, we have taken water and we have taken mercury in the test tube, right? Now, water, the cohesion molecule will be lesser than the adhesion, that is why the test tube becomes wet. So, when you are putting both, you just remove the water from the test tube, you will find the test tube becomes wet. While when you are taking the mercury in the test tube and you just remove the mercury, you will find the test tube becomes totally dry. So, reason is that the adhesion means the attraction of the molecules of the liquid and the surface on which it is kept, the attraction is there. So, that we will find in the water case, but in the liquid case we can say the cohesion is more. It means the molecule of the mercury are more attracted towards each other rather than the molecule of the mercury and the attraction with the surface. So, conversely, a convex meniscus occur when the particles in the liquid have stronger attraction to each other than to the material of the container. So, we can say in water we have the concave meniscus. You can see the meniscus shape, while in mercury case it is always a convex because cohesion is more than the adhesion. Now, let us start viscosity. Some liquids like glycerol or honey flow slowly, while others like water and alcohol flow rapidly. This difference is due to the internal resistance to flow, which is called viscosity. Viscosity arises due to the strong intermolecular forces between the molecules that holds them together and resists the passing of layers over each other. The layers of molecules of flowing liquid that are in contact with the surface are stationary. Increase in the distance between the two layers increases the velocity of the upper layer. Flow of liquid with regular gradation of velocity while passing over other layer is termed as laminar flow. Now, I want to show you before I discuss anything first example of both. I will show you this with the activity. Now, we will compare the more viscous and there is no viscosity in the liquid. Now, let us compare the flow. I am going to pour this water into the glass and you can notice the flow. It is very easily, very rapidly it occurs. If we pour gum on the plate, you find it takes time also, and it is quite viscous, very, very viscous liquid is this. Now, when we can say that it goes in the layers of the molecule flowing liquid that are in contact with the surface, that is the stationary. I want to explain this understand in this way. Suppose this is one plate, another is this one. How to understand the viscosity better in this way? These two are suppose stationary faces. When these two stationary faces are there and suppose in between the water molecule is there, we can flow the water very, very easily because intermolecular force of attraction is lesser in this as compared to the gum or the honey. Let's take honey now. Suppose honey is there in between. This is known as the stationary phase. When we are pouring honey like this, so the honey layers, you can see because the distance between the layers over there, the layer of the honey which is directly in contact with my hand or the surface will go little slowly. The above which are there will move little faster. The above will move little more faster. So, we can say this flow is a unique kind of flow is there. This is known as the laminar flow, and we can say the gradation is formed over there. So, that is why what happens, you will see that when it is flowing, the above layer comes faster than this layer, because this is in contact with the surface of the container in which it is kept. So, the intermolecular forces, that cohesive forces, and each layer experience a force of friction from the adjacent layer, which I just told you. So, this force of friction, that is F, is present between the two layers of them. So, now I am going to tell you all this I will explain this on the board to you. As I showed you on the experiment, the layers, how it works basically. So, I drew over here, you can see, suppose this is the surface on which the liquid is kept, that is the honey is kept, and it is the laminar flow. This is what I explained to you earlier. So, due to the intermolecular forces, cohesive force, each layer experiences a force of friction from its adjacent layers. This force of friction F between two layers depends on the area of contact between them, A, distance between the layers, that is this and this, that is dx, and difference in velocity between the layers, this is du, and the difference how it comes, that I explained to you. The layer which are away from the surface will move faster than the layers which are near or the closer to the surface. Now, taking these quantities, how all are they related? We can say that this is a force of friction. We get a formula, F, that is force of friction, is equal to eta A du upon dx. So, here eta is a Greek letter. It is called the coefficient of viscosity, and du upon dx is the velocity gradient between the layers. Now, how we can reduce the viscosity unit? As we know that if we take this one in the CGS unit of viscosity is dyne per centimeter square, or if you take MKS, we have Newton per meter square, or we can say it is a Pascal second. So, the two units and otherwise the viscosity unit is also known as a poise. So, we can say 1 PAS is equal to 10 P or 10 poise. Now, viscosity depends on temperature and pressure also. Viscosity decreases with increase in temperature. With increase in temperature, as you know, kinetic energy of the molecule of liquid increases, which can overcome the intermolecular forces, hence the liquid starts flowing faster. So, if you heat it, the molecule will become a little lesser viscous. Then viscosity increases with increase in pressure. On applying pressure, the molecules tend to become more closer to each other, hence liquid starts flowing slowly. Now, let us sum up what we have studied. Boiling point, first we have done the difference between the evaporation and boiling point. Boiling point is what exactly? It is a temperature at which the vapor pressure of the liquid becomes equal to the external pressure. Then we discussed about surface tension. It is a force acting on an imaginary line of unit length drawn on the surface of the liquid and acting perpendicular to it towards the liquid state. And due to the surface tension, liquids tend to have minimum surface area and show phenomena of capillary rise or fall and curved meniscus. This I showed you with the help of the experiments. Viscosity is the, and then we discussed about viscosity. Viscosity is the internal force of friction to the flow of liquid. Thank you.